Welcome to section 3.5, Implicit Differentiation. Our goal today is to find the first derivative of functions that are not explicit in nature. The procedure to doing this is to find the derivative of the function using our basic derivative rules for y prime or dy dx for the derivative of our variable y. Basically, we're going to go through and take the derivative, and wherever we see y, you'll replace it with y prime or dy dx. We'll remove any parentheses if necessary. We'll group all of our y primes together on one side of the equation and group all other terms on the other side of the equation. And then we'll factor out y prime for all of our terms that have a y prime. That way we get y prime all by itself. Let me show you what I mean. Here we have an equation, 7x squared plus 5y minus 21 equals 0. First, let's solve the equation for y and find the derivative. This is what we're used to. So if I take the equation 7x squared plus 5y minus 21 equals 0, I want to get y alone, so we'll add 21 and subtract 7x squared, and we'll be left with 5y equals 21 minus 7x squared. Last, we'll divide by 5, so everyone gets divided by 5. We'll be left with y equals, and we'll put this in y equals mx plus b form. So we have negative 7 over 5 x squared minus 21 over 5. I guess it's ax squared plus bx plus c. In this case, we don't have an x in the middle. We just go from x squared to a constant. Okay, we found y. Now we take the derivative. So y prime, the derivative of negative 7 over 5 x squared, so negative 7 over 5 x squared is going to be 2x. That's going to become a 0, so y prime is negative 14 over 5x. There's our derivative. That's using it or finding it the way we're most comfortable with, what we've just learned in the past few weeks. Now let's find the derivative using implicit differentiation. So we're not going to solve for y, we're just going to go through it and take the derivative where everything is. So I'm going to bring my equation down here. 7x squared plus 5y minus 21 equals 0. Okay, let's take the derivative of 7x squared. 14x plus constant of 5, the derivative of y will be y prime, and the derivative of 21 is 0, and the derivative of 0 is 0 still. Now we solve for y prime, so we'll move our 14x over, 5y prime equals negative 14x, divide by 5, and so y prime is negative 14 over 5x. And that's a good thing because it matches. But this is showing you the two different ways that we can find the derivative. In some cases, we won't be able to solve for y easily, and so taking implicit differentiation will be the better way to go. Use implicit differentiation to find the first derivative and evaluate it at the given point. 3y minus 6x cubed plus 8 equals 0. And the point we want to evaluate it at is 3, negative 2. So first, let's differentiate. 3y, the derivative will be 3y prime. 6x cubed, the derivative 6 times 3, 18, x squared. Derivative of 8 is 0, and the derivative of 0 is still 0. So let's solve for y prime. Move the 18x squared over. We'll have 3y prime equals 18x squared. Divide by 3. Y prime equals 6x squared. And now we can evaluate it at this point. So our x value that we're going to be plugging in is 3. So at y prime, our derivative, we're going to plug in x of 3. And this is going to give us 6. 3 times 3 is 9, and 9 times 6 will give us a 54. So there we go. We found the derivative, and what that means is we have found the equation of the slopes. And in this case, at the point 3, -2, the slope of the tangent line is 54. So it's positive, and it's very, very steep. Use implicit differentiation to find the first derivative and evaluate it at the given point. Now we're looking at 5xy squared plus 8y minus 3x squared equals 0, and the point is 1, 4. Okay, so let's implicit differentiate 5xy squared. Now we have to use our product rule. So we'll take the first times the derivative of the second. So derivative of y squared is going to be 2y, and we took the derivative of y, so y prime, plus the second times the derivative of the first. 5x is just going to be 5. The derivative of 8y, so 8, the derivative of y is y prime. And the derivative of 3x squared, 6x. Derivative of 0 is still 0. So in this case, we need to make sure that we are not forgetting our product rule. I'm sure we'll see one where we need to do a chain rule, a quotient rule. All of those rules are coming into play even with implicit differentiation. Now let's solve for y prime. So what we'll do is let's multiply this out and this. So we'll have 10x y prime plus 5y squared plus 8y prime minus 6x equals 0. Let's move anything with no y primes. So the 5y can go, and the 6x can go, because those do not have any y primes at all. So that way on this side we have a y prime in each of our terms, and on this side we have no y primes. Okay, now we will factor a y prime out of each of these terms. So we have 10xy left plus 8 left. On this side it stays the same. And now we can divide that off of the y prime. That way all we're left with is the y prime. negative 5y squared plus 6x over 10xy plus 8. The x value that we're interested in is a 1. The y value we're interested in is a 4. So here our y prime, let's see. Negative 5y squared plus 6x over 10xy plus 8. If we plug in x and y. So negative 5, our y value is 4 squared, plus 6, our x value is 1. 10, our x value is 1, our y value is 4, plus 8. This is going to give us 4 times 4 is 16. 16 times 5, we have negative 80 plus 6 over 40 plus 8. So we've got 74 over 48. And we can reduce, I suppose, 37 over 24. This is our derivative at that specific point. Use implicit differentiation to find the first derivative and evaluate it at the given point. 7 natural log of y equals e to the x plus 4x squared minus 3y squared at the point 0, 3. Okay, so we have our function. I'm going to bring it over here, that way we have enough room to work. Let's take the derivative. We have 7 times natural log of y, so we'll pull the constant out front. The natural log y, derivative of natural log of y, is going to be 1 over y, so we'll have 7 over y, and we have to do y prime, derivative of y, that chain rule. Then we have the derivative of e to the x is itself e to the x plus the derivative of 4x squared, 4 times 2 is 8, 8x. Derivative of 3y squared, so the derivative of 3y squared, 3 times 2 is 6y. And then the chain rule, y prime, the derivative of y. Okay, now we need to do our best to get all the y primes on one side and everything else on the other. So I will add 6y y prime to both sides. This gives us 7 over y, y prime, plus 6y, y prime, equals e to the x plus 8x. Let's factor the y prime out. So we have 7 over y plus 6y equals e to the x plus 8x. And now we can divide that away. 7 over y plus 6y, 7 over y plus 6y. Y prime is e to the x plus 8x over 7 over y plus 6y. The point that we want to look at is 0, 3. So x is 0, y is 3, we've got e to the 0 is 1, 8 times 0 is 0, 7 over 3 plus 6 times 3 is 18. Find a common denominator, we can add those. 61 over 3. And so, really we're taking the reciprocal of that, 3 over 61. Use implicit differentiation to find the first derivative and evaluate it at the given point. X squared times y cubed plus x times y squared minus 6y plus 4 natural log x minus 6 equals 0 at the point negative 2, 3. Okay, we're trying to get a little more complex now. Here we go. So let's bring our function over here. Now let's take the derivative. So now we have a product, the first times the derivative of the second, derivative of y cubed, 3y squared, y prime, plus the second, y cubed, times the derivative of the first, 2x. Now we have another product, the first times the derivative of the second, the derivative of y squared is 2y, y prime, plus the second times the derivative of the first, the derivative of x is 1. The derivative of 6y is going to be 6y prime. The derivative of 4 natural log of x, so natural log of x is 1 over x, so we have 4 over x. And the derivative of 6 is 0, and the derivative of 0 is 0. Okay. Now let's multiply some things out. 3x squared, y prime, plus 2xy cubed, plus 2xy, y prime, plus y squared, minus 6y prime, plus 4 over x equals 0. Now let's move anything that does not have a y prime, so minus 2xy cubed, minus y squared, minus 4 over x. Three x squared, y prime, 2xy, y prime, minus 6y prime equals negative 2xy cubed minus y squared minus 4 over x. Now let's factor out the y prime from all of these terms. Y prime will be left with 3x squared y squared plus 2xy minus 6. This side we didn't change anything. And now we can divide that off of the y prime. So our derivative, y prime, is negative 2xy cubed minus y squared minus 4 over x over 3x squared y squared plus 2xy minus 6. The point we're interested in is negative 2, 3. So let's plug that in. We'll have negative 2 times negative 2 times 3 cubed minus 3 squared minus 4 over 2, 4 over negative 2 over 3 times negative 2 squared times 3 squared plus 2 times negative 2 times 3 minus 6. And if we multiply and subtract all of these things, we should get 101 over 90. Okay, let's use implicit differentiation to find this one. Let's rewrite the square root of 2y cubed minus 16 using exponent properties. So if we take the square root, that's the same as raising it to 1/2 power plus 5x squared plus 13 equals 0. Okay, now we can use the power rule. So 1/2 times 2y cubed minus 16 to the negative 1/2 times the derivative of the inside, so 6y squared, and chain rule of y prime. Derivative of 5x squared, 10x, derivative of 13 is 0, derivative of 0 is 0. Okay. If we multiplied these, we would get 3y squared times 2y cubed minus 16 to the negative 1/2 y prime. And why don't we just move that 10 over? So negative 10x. That way it's not, it doesn't have a y prime on it, so we're moving it anyway. Okay, this one is everything multiplied times y prime, so we're going to divide it off. 3y squared, 2y cubed minus 16 to the negative 1/2. All gets divided off. So y prime is negative 10x over 3y squared times 2y cubed minus 16 to the negative 1/2 power. But we don't like having negative exponents, so we'll just move it to the numerator. 2y cubed minus 16 to the 1/2. If you really want to, you can put that in a radical. Okay, let's evaluate it at the point 3, 2. So we'll have negative 10 times 3 times 2 cubed minus 16 to the 1/2 over 3 times 2 squared. So the top actually becomes 0. So the whole thing will become 0. 0 slope. It must be like the top where we would have a horizontal line for our slope, or the bottom, one or the other. Okay, our last example for today, using our implicit differentiation. Let's do this. 4 plus y to the 4th plus 6y equals x cubed minus 2x plus 7. Okay. let's take the derivative. I'm gonna rewrite it over here actually. The derivative of the first, so the derivative of 4 plus y to the fourth, let's use the power rule. 4 times 4 plus y to the third, derivative of the inside. Derivative of 4 is 0, derivative of y is y prime. Derivative of 6y, so 6y prime. Derivative of x cubed, 3x squared. Derivative of 2x is 2. Derivative of 7 is 0. Okay, all the y primes are already on one side and everything else is on the other, so let's factor the y prime out. We're left with 4 times 4 plus y cubed plus 6. Now let's divide that off. And so our derivative, 3x squared minus 2 over 4 times 4 plus y cubed plus 6. If we evaluate it at the point 1, 0, we will have 3 times 1 squared minus 2 over 4 times 4 plus 0 cubed plus 6. On top we'll have 1 over bottom we'll have 262. So in summary, take the derivative, get y prime alone, and then evaluate it at the point you're interested in.